All right. So this one's going to be a not symmetric one where the x and the y or the x and the z will not be equal and they'll all be unique. Okay. So let's look at this one. A rectangular box is resting on the xy plane with one vertex at the origin. The opposite vertex lies in the plane. Find the maximum volume of the box and its dimensions. Okay. So picture is worth 1,000 words. Okay. So let's see. How do I graph the plane? What's the x-intercept? If you have an x-intercept, that means the y's and z's are both zeros, so you hide them. So you're kind of going, when does 6x equals 24? That's at x equals 4. 1, 2, 3, 4. Okay. I could do the y1, which is when does 4y equal 24? That's at y equals 6. Okay. And I have one more. I could do the 3z is 24, and that's at z equals 8. Okay. And I can piece it together. It's not really a triangle, but that's the best way to see it. Okay, it's just kind of slanted, going up to rest on the plane as so. Okay, and then my box, let's see if I can draw this. My box is inside the kind of zone in there. The origin is right there, and there's a corner there, and it kind of goes like this. So and then up until it hits the plane, and then it gets tucked in like that. So this part right here is touching the plane, and the back corner, okay, is on the origin. Okay, so there's my box. Okay, if you want, you can label that point x, y, z, and that point is hitting the plane again, hitting the blue plane there. Okay, so let's start this. I'll go with my G, which is the given, was basically the picture that I drew. Okay, and this equation. So you could argue it's the picture and the equation 6x plus 4y plus 3z equals 24. Okay. Now my L is I want the max volume again. So volume is, if I have this as x, y, z, that's an x, that's a y, that's a z. X, y, z would be the volume, because the way I labeled the point, that is the I guess I should have done it a little bit better. This would have been the x, sorry, and that would have been the y. But there's your dimensions. Okay, now I'm going to take the g, I'm going to solve it for one of the variables. And it does not matter which variable you solve it for. Any one of them you can solve for. It does not matter. Let's solve for the y again. So 4y equals 24 minus 6x minus 3z. So y equals 6 minus 3 over 2x minus 3 over 4z. And again, I promise you, it didn't matter which variable you solved for. Okay. Now my t part would be volume is x, 6 minus 3 over 2x minus 3 over 4z times z. Okay. So volume is 6xz minus 3 over 2x squared z minus 3 over 4xz squared. And notice, like I said before, that this one is not symmetric. So that means x will not equal z. And the reason it's not symmetric is this number and this number differ. If those were the same number, then you have it. You could say that x and z are the same, but they're not the same number. They're different numbers, so it's not balanced, so you don't know what x and z are yet. They're just definitely not equal. Okay? So now we can take some derivatives. So Vx is 6z minus 3xz minus 3/4z squared. I'm going to set him equal to 0. And I'm going to pull out a negative. I don't like that 3/4 as a fraction anywhere, so I'm going to pull that out. Let's see what I get. So if I pull out a negative 3/4 z, I'm going to do this. I'm going to go backwards again. So then that means I have a z from the last guy. Then if I pull it out of the middle guy, I'm going to have a plus 4x. And then I'm going to have on this last guy a minus 8. Take a look at that if you want. Okay. The reason I pulled out the negative 3/4 is so then the inside would not have a fraction in it. Okay. And I'm also going to do it with the VZ. And this derivative is, I can't see it, so pull up. Here we go. VZ, 6x minus 3 over 2x squared minus 3 over 2xz. Set him equal to 0. So I don't like that 3/2 as a fraction. I'm going to pull that out. Okay. And I have a z. Again, I'm writing it backwards. I have a z plus an x. And if I take 3/2 out of 6, that should be 4 left over, and a minus 4. Okay. Now again, I need to solve these. This piece and this piece are redundant or dumb, because this is saying z equals 0, which means my volume is 0. X equals 0, my volume is 0. That doesn't help. So the part that does matter, that's going to give us the essence, the main part of this, is this and that. So let's line those up. I got z plus 4x minus 8 equals 0. And z plus x minus 4 equaling 0. I'm going to subtract right away because those z's are going to go bye-bye. I get 3x minus 8 minus negative 4 is plus 4. So negative 8 plus 4 is minus 4. So x equals 4/3. Okay. So if x equals 4/3, let's just plug that right into this one. And I got z plus 4/3 minus 4 equals 0. So z would be 8/3. And where can I go to get the y? Where can I go to get the y? Haha! On that I one again, y equals 6 minus 3/2 x minus 3/4 z. So I already know again who x is and who z is. So I'm going to plug that right into there, and I can get who y is. And do that. Y equals 2. And if you multiply those, I get 64 ninths. Okay? That, again, was all the evaluating. Or you'd want to go do the second derivative test. Okay? So, second derivative test, let's see. I could do vxx, and vxx would just be minus 3z, and vzz would be minus 3/2 x. Vxz would be 6 minus 3x minus 3/2 z. And I can plug in the values that I have. So plugging in a z there, that would be -8. Plugging in, what was x? 4/3. 4/3 into that one is -2. And then 4/3 and 8/3. 4/3, this is a 4/3. This is an 8/3. Let's see if I can do some math here. This is going to be 6 minus 4 minus 4. So minus 8, 6 minus 8 is -2. Okay. So then the d guy would be -8 times -2 minus the -2 squared, and that is positive. And so I got d is greater than 0, and vxx is less than 0, so I have a max. Okay? So there was that one. And let's try one more. We'll do it on this one here. At least let's just start this one. Okay, profit obtained by producing X units of product A and Y units of product B is approximated by this model. Find the production level that produces a max profit. What is the profit? And you can assume that there are no restrictions on the company, meaning they can produce as many units as possible. Okay, what's nice here is it's already in 2 variables. So since it's already in 2 variables, we don't have to do any merging from 3 variables down to 2 variables. So really it's just doing the derivative and making sure we can do the math. Basically this one here is exactly like yesterday's homework. It just now has a story problem to it. Okay? So I could do px, and I get 8 minus 0.001 derivative time 2x plus y. Okay. And then I could do py and get 10 minus 0.001 x plus 2y. I want to set both of these equal to 0. Okay, now I have to solve this. Okay. Solving it, it's just already a linear algebra problem. Okay, so I would probably go with this and get 8 equals 0.001 2x plus y. Let's divide by the 0.001. and I get 2x plus y equals that thing, which has lots of zeros when I divide it. 8 divided by 0.001 is 8,000. On the blue guy, I could do the same thing. 10 equals 0.001 x plus 2y divided by 0.001. And I get 10,000 equals x plus 2y. Okay. Now, maybe I line it up as, okay, so I got 2x plus y equals 8 grand. And x plus 2y equals 10 grand. And let's multiply this guy by -2 and subtract. Goes away. Y minus 4y is minus 3y is 8,000 minus 20,000, negative 12,000. So y equals 4,000 units. And you can plug that back in to get x. And you would get x is 2,000 units. And am I done? No. You need to verify for me that it is most definitely a max. Okay? And you would do that, or I'm getting tired, so I'm not going to do it for you, but you would take the pxx, the pyy, the pxy, and verify with the second derivative test. Okay? So, there was a lecture, optimization. It rocks. Calc rocks. And what's crazy is in Calc 3, tomorrow we're going to do another type of optimization which should blow your mind. Here's homework.